Alright, so we're going to be learning about some rigid transformations. So that means you can rotate a shape, change it all about, it doesn't matter. You can push it this way, you can rotate it, you can reflect it, you could do anything. The only thing you cannot do is like change its size or just create a new shape. But as long as it's similar to the shape, or actually congruent to the shape that it is right now, then it's a rigid motion. So I'll explain that in a little bit more detail. So we have a coordinate plane right here and a triangle. And so we're going to perform a couple of different rigid motions on it. So the first one is going to be reflect over the, so I'll just put these right here. So the first one, and then I'll delete it and do the same thing. So we have reflect, let's go x, so I'm gonna have 3 reflects, so we're gonna do and then we got x, and then let's do x equals 3, and I'll actually do y equals x as well. So y equals x. So, alright, so first we got the x-axis. So this little line right here that's going horizontally is the x-axis. It's the horizontal line, and it's also denoted by an x on this one. It may not be on other ones, but it's going to be today. So we have a triangle here, and we can count the points, and so this first coordinate is at -2, 1, because it's 2 to the left and 1 up. The x is always first in the ordered pair, and this one is going to be the same height, but when you reflect over some axis, you're going to change the values, and if it's over some axis, you're going to do the exact opposite. Oops. So now, if I move this to be right here, that would be a movement. I translated that. That's going to be later on, but we instead want it to be, this is completely reflected. So if I put a mirror over this line and folded it in half, this little thing, this little line would match this line. So if I rotated this and put it on this point, and roughly match them up, we will see this is a reflection. These two are mirror images of each other. And so I'm going to write down the points over here. Alright, and so then we're going to write it as the pre-image, and we're only going to do one set of coordinates so we can see what's happening here. So we got -2, -2, 1. Okay. And so, and so we still have -2, but the y is now -1. This is not a minus, this is a, like, I'll do a comma. I guess that would make sense. Alright, so now, okay, x equals 3. it's not an obvious line until you see. So we're going to have the same distance on each point from that line. Okay, so we have x equals 3, so 1. So this is 0, so this is the x-axis. This is point 1, or this is 1, 2, 3. And so now we're going to have the same distance from this line on either side. Actually, I'm going to do x equals 1 because I would like to have majority of the triangle in there. Alright. So this is the x equals 1 axis right here, or the corner of the triangle. So imagine a line just going through, oops, x equals 1. So this is the line. So if you had a graph y equals 1, or no, x equals 1, this is what you would graph. The y values would just keep changing, and the x values would all be 1. But if we put the triangle on this corner right there, they're not the same distance apart. So this is a distance of 1, 2, 3 to the left from this corner point. So this corner point needs to be 3 to the right. So we have 1, 2. So we got 1, 2, 3. And the other points should fall into place, but it's always a good idea to do a couple of them. So then we're going to do reflect over x equals 1, so that'd be 4 over and 1 up. No. Or negative 2, 1, and then 4 over 1 up. So I'm gonna do that. Right, and then we're going to do reflect over the y-axis. Okay. So this is going to look very similar to the last one. So this y-axis is x equals 0. That could be another thing that it's called. So the y-axis is this line, this vertical line. So it's 2 to the left. This point is 2 to the left of it. So 2 this way. And if we also wanted to count this point, 1, 2, 3, 4, 5, 6, 7, 8, then it's going to be the same distance on the other side. Or this is a square coordinate plane, and many of the ones that you have will probably be, so the same distance from the wall as well. So it's just a mirror image, just the line is the y. So let's copy this, and then we're going to look at the algebra behind it. I think we're only going to do reflections today. Alright, y equals x. That's an interesting one. In fact, I will actually draw the line on this one. So if you graph the equation y equals x, you're going to get a line that's going to look something like this. And so it's not going to be as bumpy. I just can't draw very well. But it's going to be a straight line through each little thing. It's going to have a slope of 1 at every single point. But that's a general idea of it. So it's going to just be a line like this or so, but it goes to the origin. And so if I said, what's x? It's the same value as y. So x is 1, y is 1. X is 13, y is 13. X is negative 3, y is negative 3. So that's what that line shows. So y equals x. We're going to reflect it over this axis. So Alright, so let's go. And so then we're going to have 2 points. So let's start off with -2, comma 1 like always. And then we'll have some set of coordinates. And then we're going to have our other set of coordinates. So let's figure out this other point down here that we're going to use to figure out this shape. So that's 1 up, so the y is 1. And then it's -1, 2, 3, 4, 5, 6, 7, 8. -8. Probably said that earlier, but oh well. So we got -8, 1, and -2. Or, yeah, -2, 1. So y equals x. What we are going to do is we're going to swap the numbers, and that might be slightly confusing, but you'll understand this better when we do rotations. But y equals x means we're going to swap the numbers. Alright, so if we had rotated, if we reflected over this axis, so this -2, 1 would become 1 over -2. But this makes sense, right? Because this is 3 from here, and this point is also 3 from here. If I drew a line, so we got 3 from this point, and then we got 3 from this point. 1 and 2, 1 and 2. So it's the same distance, but we haven't gotten the whole entire shape yet. We only got the other one, so let's do -8, 1. So we got this first set of coordinates over here, so let's do that. So it's 1, -2. And then -8, 1, so negative. So then we're going to switch it to 1 over, 8 down. So now it's going to look like this. And you can see that if I folded over this line right here, you could just imagine that these two would flip onto each other. So that's -2, I'm sorry, 1, -8. So now I'm going to give you a couple of algebraic things. Alright, so we have just some blank notes right here. So we have just x, y, x, y. And so we're going to figure out how to move these values around to get any of these. And this is the less intuitive part. So if you don't learn like this, I'm sorry. But if you have a formula sheet and know how to use formulas well, then I would strongly recommend just writing this down. So we're going to figure out what they all translate to. So let's start with the x-axis. So we went from -2, 1 to -2, -1. So the first value stayed the same, but you inverted the y. So, but that does not mean change the negative to a negative. So if we had the exact opposite, if this figure started like this, and I said reflect over the x-axis, and we didn't know this image right here. We're just going to move it off to the side. Okay, and so it said reflect over the x-axis. We wouldn't just say, alright, so -2, -1 of a -1, that's still -1. No, no, no. You'd do the opposite. So the negative of -1, it's like multiplying by a -1. So -1 times -1 is +1. Because that's how math works. Alright, and so then we're going to move it like that. Okay, so it's just going to flip the number. It's going to add or remove a negative sign at the end. or at the beginning of that number. And so the y-axis, we could do the same thing. So let's look at the y-axis. So, wait, I don't think this is the right y-axis. -2, -1, and 4. Yeah, that's the wrong one. I'm sorry, I wrote the wrong thing down. It's 2, 1. I was looking at this one up here. But we can look at this. So we went from -2, 1 to 2, 1. So this is what I was talking about earlier. You're just multiplying by -1. -2 times -1 is +2. So, for the y-axis, what we did is we just swapped the x value and kept the y the same. Alright, so now y equals x axis. So this is interesting. So we got -2, 1, and then we got 1, -2. The numbers are the same, but look, oops, they're just flip-flopped. You see, -2 is the y, and 1 is the x. So, if instead of y comma, or x comma y, we could do y comma x. So whatever they say, if it's 1, 4, so 1 over 4 up, so this point right here, where the tip of the mouse is, and then we'll do, instead, 4, 1. Alright, so let's think about this one logically. So if we had the same thing, but instead it's just over this axis, because that's what this is, this inversion of that function. So if we wanted, so there's a point right here, we would have a point right here. And then, alright, so the distance between that line is going, so we have this line like this, and the distance is going to be 1 horizontally at, so we hit this point in the same spot, and there we go, and then it's going to be the same thing, just rotated. So what did we do? Well, we changed the values, right? So how did we change them? So we have this line, and from -2, 1, we went to 2, -1. So the negative x-axis is going to be the same thing, but just the values are negative. So yx negative, negative. Alright, so that's that one. And then we're going to do x and y equals n. So that's going to be like this practice one over here. So x equals 1. So what we're going to try and figure out is an algebraic formula for this. So when x equaled 1, it's going to be like the y-axis flip. So let's start with that. So we're going to start y-axis flip, and so the y-axis flip was -x. So, because this is an isosceles triangle, it's okay. I could do that, but normally this would go like end over end. Times the number we added from it. So let's just write out the formula. So we got x equals negative y plus 2n. Whatever you're adding. So let's test it out for these two values, okay? So we got, let's start with x equals 1. So x equals 1 and negative 2, 1. So if I did negative x, that's 2. I'm going to do 2 times this n, which is just going to be what x is added to over here. So 2 times 1 is 2. So 2 plus 2 is 4, and the y value stays the same. Awesome, that worked. That is indeed where this point would go. Now, let's try negative 2, and let's try 0. Okay? Actually, let's do negative 2 and negative 1. So this line, negative 2 right here, is negative 2. X equals negative 2. So we have negative, so that's 2 right here. So this is where it would be without anything else but x equals negative 2. So we're going to do 2 times negative 2. And so that's 4. So we're going, or 2 times negative 2 is negative 4. So adding a negative 4 would be subtracting it. So we're moving it right here. We're moving it 4 to the left. And if I reflected something over the negative 2 axis, this is the, oops, that would be the mirror image of itself on that axis. So we can use the same idea to figure out y equals n axis. So we're going to start, so if I reflected over y equals 1, or y equals negative 1 right here. It's the same distance, 2 and 2. So this is the correct. So now let's figure out what we did. So we started with the inverse of the y, and then we're going to add plus 2 times n. Will that work? Is that what we did? Let's check it. So we went negative 2x and 1 up. And so negative 2, negative 2. So that's fine. Now we got 1, negative 1, plus 2 times 1. So that is how you do the algebraic for reflections. But I'm going to do one more thing.